This video is for the standard algorithm of dividing multi-digit whole numbers. So standard algorithm calls for you to rewrite a statement like this into this form. So what you do, you start off, you say, does 4 go into 2? No. 4 goes into 22 though 5 times. When you say 4 times 5, you get 20. So now I'm going to subtract the 20 from the 22, and that gives me 2. Now I'm going to bring down this 3, and that gives me 23. 4 goes into 23 5 times again. 4 times 5 gives me 20. And then you subtract it. Now these are just rules that I memorized. These are procedures that I was taught back in 5th grade. There isn't any conceptual anything that I can show you for this algorithm. I can show you how it works, and that would be the conceptual way to show it. These are just rules and procedures. So 23, subtract 20, you get 3, bring down this 6. 3 goes into 36 9 times. 4 times 9 is 36, and you get 0. So there is no remainder. So, like I said, these are just procedures. These are rules that I memorized when I was in 5th grade. I remember being ridiculously confused because I was taught to just put these arrows. I didn't know why we were bringing it down. I didn't know why we were subtracting. So eventually I just memorized the rules, and it just kind of stuck with me. So why does this work? The answer is always place value. Sorry. So when you say does 4 go into 2, you're actually saying, like, when you look at it, you're actually saying does 4 go into 2,000? And just for the purpose of going with standard algorithm, we're just going to say no, 4 does not go into 2,000, even though we know that it does. So does 4 go into 2,200 or 2,200 is actually what we are saying here. And yes, it does. So 4 into 2,200. This is simple because it would be more simple if we would use the 2,000. But we said that it went into 2,200 500 times. Not 5 times. 4 doesn't go into, it does go into 22. But what we wrote it in the hundreds place. And with us knowing that we wrote 5 in the hundreds place, that means that it's 500. Not just 5, 500. So 4 can go into 2,200 or 2,200 500 times. So now what we did, we said 4 times 5, or 4 times 500 actually, gives us what? We wrote 20. Does 4 times 500 actually give us 20? No. It gives us 2,000. So now why do we subtract it? It's because we're looking for what goes into 2,200, but we only came up with 2,000 when we multiplied it times 5. So now we're trying to figure out how much more we have to go, how much more 4 can go into. So we're left with 200, which is what we got here. So if we hadn't brought down this 3 yet, so this is the 200 that we were talking about. If we hadn't brought down this 3 yet, that's what we wrote. 22 minus 20, or 2,200, 2,200 minus 2,000 would give us 200. Do you see that? 22, 2,236. 4 times 500. 4 times 500 gives us 2,000. We subtract it because it did not give us the full 2,236. It only gave us 20,000, so we still have to find 236. So we're going to subtract it, and we find that we have 200 left to go before we carry down more. So that's what we did. So now we're going to ask ourselves, how many times does 4 go into 200? Right here, we said, how many times does 4 go into 20? And we got 5. Or we said 23, actually, because there was a 3 here that we brought down. So, we said it went into it 5 times or 50 times. So I'm going to change this to a 3 because that's what we did. We brought down this 3 because we still have 236 left to go. We're just going to use the 6 down here. So 4 goes into 230. We said 50 times because this is the tens place. I guess I should have switched colors, but you know, we're already here. So we said it went into it 50 times. Now 4 times 50 does not give us 230. 4 times 50 gives us 200, so we're going to subtract it out, and that will give us 30. We have 30 left to go. And that's exactly what we did here. If we hadn't brought down this 6 yet, we would have these zeros in the placeholders instead of that long arrow saying bring it down. So 230 minus 200 gives us 30. That's what we have here. So now we're going to keep going. We're going to bring down that 6 because we can't forget that we still have this 6 left. So now, how many times does 4 go into 36? That's one of our multiplication facts, so we just remember that that's 9. So now, if you look back at what I just did, following standard algorithm way, I got a 9 here, a 50 here, and a 500 here. That is extended notation for 559. So that's all you're really doing. You're not saying how many times does 4 go into 22. You're saying how many times does 4 go into 2,200. And each time you bring down something, all you're doing is remembering that you still have to put 4 into that. So when you said how many times does 4 go into 22, you only used 2,200 of this number. You still had 236 left. So that's where we got this, 230, and then we had the 36. Each time we brought back a number from here because eventually we had to show how 4 goes into each. How 4 goes into the whole 2,236. So, let me show where the 2,236 is. The 2,236, here's 2,000. Here's the 230. And here is the 36 here. I'm sorry, it's the 200 here. Not the 230 there. Maybe I should keep these in the same color, huh? It's the 200 here. So we subtracted 2,000 here. We subtracted 200 here. And then we subtracted, well, it went into it perfectly, 36 here. So we didn't have to subtract it. So this is where we get our 2,236. It's right there. And that's why standard algorithm works. It's all in the place value. Even though you think that you're saying 4 into 22, it's really, just look at the place value and you're really doing, bigger numbers. That's just a little more scary for kids. If you show a 4th grader or a 5th grader, how many times does 4 go into 2,200, they're going to be like, what? But if you show them 22, they can totally do that. So I think it's more of not working with huge numbers with the standard algorithm.